Dr. Vishwanathan, Department of ANC, Rajya Institute of Technology, Hassan. Today I am explaining and demonstrating how to design and test the biased clampers circuits by using the multi-sim software. So, clamper circuit. So, clamper circuit is a circuit which is used to design to add a DC level to an AC level. These signals are shifting the entire signal waveform either upward or downwards. Clamper shift an input signal by an amount defined by an independent voltage sources. Mainly, the clampers are classified into two types. One is positive clamper, another one is negative clampers. So, in the positive clampers, once again, we are further divided into the with and without external bias voltage, bias signal. Same in the both positive and negative clampers. We'll discuss in next slides. So the main principle of the clamper circuits, it is operated by charging a capacitor to the peak value of the input signal during the one-off of the cycles, and the diode allows the current to flow in a specific direction. Charging the capacitors and store the charge, then shift the waveform either upside or down based on the clamper configuration. It is positive or negative clamper circuit. So this is the circuit we are using for designing the negative clamper. It is a negative clamper. So the diodes are connected in the shunt wise connection. So negative clampers reverse the diodes. So in negative clamper, the example of without reference. In this circuit, the output is shift the waveform down. So the highest point is at 0 volt. The highest point is at 0 volt. From observe the output, red color indicated the input lines, and the output lines are indicated in the gray color, that is green, light green colors. So observe that. So output is shifted to the downside, and the maximum highest point is almost equal to the 0 voltage, but it is a practical small voltages appear in the positive side, that is diode voltage. Okay, and observe that here you observe that in the positive off cycle diode is forward bias conditions, the operation of this negative clamper. So apply the KVL to the circuit. So V in minus capacitor voltage and diode voltage is 0. So in my design, I am choosing the peak to peak voltage is 10 volt. So positive voltage is 5 volt and negative voltage is 5 volt. Therefore, the positive voltage 5 volt I am consider, and diode voltage is 0.5 I am chosen. So therefore, octane is 4.5. Similarly, in the negative off cycle, V in minus VC minus V naught is equal to 0. V naught is equal to V in minus VC, because diode acts as a reverse bias. Okay. So when V in is 0, V naught is equal to minus 4.5. When V in is 5 volt, then V naught is 0.5 volt. So V in is minus 5 volt, V naught is how much? Minus 9.5. The maximum output voltage shifted to the negative side, the maximum voltage is minus 9.5. For input, plus 5 volt to minus 5 volt. So observe the output waveform in negative clamper circuit. Output, the positive value is also shifted to the downside. Okay, this is the example of a negative clamper. And positive clamper similar to the negative clamper, but just flip the diode or reverse the direction of the diodes. Okay, 90 degree. So now once again observe the output waveform. The output shifted to the positive side. Positives in the negative clamper, negative side it is clamped. Signal is clamped to negative side, but in positive side, just understood that signals are clamped to positive sides. So operation during the positive off cycle, diode is in reverse bias. Then V naught is equal to V in plus VC. When V in is equal to 0 volt, output voltage is 4.5. V in is 5 volt. If input voltage I give 5 volt, then output is equal to 9.5 voltage. if the input voltage is negative, that is minus 5 volt, output voltage is minus 0.5. See, this is the minus 0.5. When input voltage is minus 5 volt, output is how much? Minus 0.5. What is that voltage? That voltage is a diode voltage. And then the negative off cycle, diode is forward bias, then apply the KVL. VC is equal to minus of Vin plus VD, it is equal to 4.5 voltage. Okay, so I hope all of you understood that positive clamper and negative clamper operations. Once the completion of this negative clamper, now we need to check applying the external bias voltage to these circuits, negative clamper and positive clamper. So just this is a circuit, you observe that I'm using negative clamper by applying the DC source. These DC source are connected to series with the diode. So 2 volt. Now, so add a DC voltage source in series with the diode to change the reference level. During the positive clamper, plus V reference are placing DC voltage in series with the diode in reverse bias. So, because up to 2 volt, this diode acts as a reverse bias because it is a negative and positive is there. So, once it exceed the 2 volt, then this diode acts as a forward bias conditions. And for negative clamper, minus V reference, just polarity is changed, adjust the diode and reference according to. Okay, and these are the operations we are using. Okay, so observe that when input voltage is 0 volt, still the voltage is minus 2.5, 5 volt, 2.5, but minus 5 volt, minus 7.5. Okay, so 2 volt is reduces instead of 9.5. Why? Because I am adding the external positive 2 volt plus 2 volt to the circuits. So therefore, output is reduces instead of minus 9.5 without reference. Okay, so with reference, minus 7.5 voltage is obtained, and the corresponding waveform you observe that. So blue color indicated the input signal plus 2 minus plus 5 volt minus 5. Red color signals indicated that output signal. So improving in positive sides. Okay, these are some various clamper circuits, but input wave is not sine wave. So here square wave, you can use sine, square, triangular, sawtooth, etc. Okay, generally we are using square wave and sine wave signals. Thank you. So now we need to verify through the multisim these circuits. Therefore, I go to the multisim environment. I already constructed and executed. So first I will go to the negative clamper. So in the negative clamper, observe the circuit diagram. So capacitors I am using 100 microfarad, diodes 1N4007G diodes I am using, and resistance 10 kilo ohm, and signal generator 1 kilohertz frequency, and peak to peak voltage V1 peak voltage is 5 volt. So peak to peak is 10 volt. Okay. So now once the connection is established, okay, this is the negative clamper circuit connections. Already we discussed it in the theory part. So now after construction, the next step is simulated. So you go to the simulated analysis, select analysis and simulation, and just you run it. Okay. So run this, observe the waveform. These circuits are just to be observe the waveforms. Okay, you don't need to measure the voltage, current, and etc. So stop this run option. Observe this. Blue color indicated the input signal. Input signal, and red color indicated the output. The output is shifted to downside, negative clampers. Similarly, we need to verify the positive clamper. Just already the circuit is connection established. So just change the diode direction compared with the negative clamper and positive clamper. So in negative clamper, anode is in downside, and positive clamper, anode is upside. Okay, just run the option. Same once again, 1 kilohertz, 5 volt peak voltage, and observe the output waveform. So output is shifted to positive side. So blue color indicated the input signal, positive and negative. Output signals are shifted upside. In negative clamper, output are shifted down. In positive clamper, outputs are shifted up side. Okay. So now we need to verify by applying the reference voltage. So it is a negative clamper with positive bias. Okay, with negative clamper with positive bias. So just I change the voltage to volt I am using. Now run the program. It's not adjusted. Okay. It's 1 kilohertz frequency, 5 volt peak to peak. Then after that, just change the time scale. $10 volts. Okay, 1 milliseconds. Okay, please observe this. Okay, shifted upside. Okay, so if voltage increases, the signals is shifted from down to upside. You will just observe. Okay, signal is shifted to the down to upside, moving the signal from down to upside. Okay, so thank you. I hope you all of you understood clamper circuits, and thank you for watching. Thank you so much.